Okay, we're back with Chapter 4. We're going to talk about the Bernoulli equation and pressure variation. And in this section we have, or in this chapter, we have quite a few sections to go over. We're going to start today with just a very quick and simple description of what streamlines, streak lines, and path lines are in a fluid and how these ideas differ. We need to do this because the Bernoulli equation is going to allow us to start to describe fluid that's moving. So we're going to move beyond fluid statics and start talking about fluid dynamics and fluid in motion. We'll then follow up with a description of some tools that we're going to use to describe motion. So you can see in sections really 4.2 through 4.4 we're going to talk about velocity and acceleration and how we will use those descriptions of those quantities to describe fluid motion. So let's just do chapter 1 today, or section 1 today, on a very quick little section on streamlines, streak lines, and path lines. And so we have some definitions of these, and I encourage you to think carefully about these because we will use these concepts later on in the chapter. Turns out that we will apply the Bernoulli equation, or we will derive the Bernoulli equation along a streamline. So we do need to know what these different things are. So when we start with the definitions, the path line is the path of a fluid particle as it moves through a flow field. So I like to think of this as maybe you being in a raft on a river. Most of us have rafted around here or been on a river, or even in a lake. And so when you're in a boat, you can think of that as being swept along by some sort of flow field, and you are just being carried along with the flow. The streak lines are lines generated by a tracer fluid continuously injected into a flow field at a starting point. And at face value, you might, or at least at first glance, you might think that these two things are equivalent. And in fact, they are equivalent when the flow is steady. That is, it's not changing with time. And so we'll look at that later on. And the final definition here is of a streamline. And this is a line that is tangent to the local velocity vector at a point in a fluid. And again, the distinction between these three definitions are very subtle. And in fact, if you think about steady flow, they're actually all equivalent. So the next slide here says when flow is steady, the path line, streak line, and streamline are all the same as long as they pass through the same point in a fluid. When the flow is unsteady, these three things can be different. And so it depends on where they would be in the flow. So there's a really nice figure here that shows this concept. And what I want you to do first is I want you to only think about these two diagrams here on the left. So we have two different situations. One is where we are injecting dye, maybe a little. Actually, I should say this: we're following an individual parcel. So if these are the streamlines, these are everywhere tangent to the flow field. If this is the way the streamlines are for times that are less than, say, t0, then the flow field is going to be from left to right. It turns out that in a minute we'll look on the right-hand side for times when t is greater than t0, and then basically the flow field has changed, and we have a flow going across the page here from the lower left to the upper right. But let's just concentrate now on the horizontal lines because these are the streamlines that are for time t less than t0. And if we follow a particle that is on one of the streamlines, it will just go along the streamline. It will just be swept along at a constant speed here along this line. If we inject a dye continuously, a tracer fluid, or tracer at this point, this same point, continuously in time, the tracer fluid will just really trace out the same sort of path as an individual fluid particle, and that's because the flow is steady. Now, the problem is that what if the flow becomes unsteady? And so now let's concentrate on these two diagrams. Now we can see that at times t greater than 0, the flow field has changed. It's become unsteady. The flow has changed direction. And what we find is for the individual fluid parcels, they will have been swept down here in time t less than t0, but then at time t equals 0, at times t greater than t0, the particles will start to go up on to one of the new streamlines or the new velocity field. Now, this is different for a streak line, because what we have is we have a continuous, for times t less than t0, we have basically a line in the fluid. And at time t equals t0, that line will be right here. But as soon as this encounters a new flow field, the dye being injected right here will follow along this line, and this line will be swept along with the flow. So the key point is that you can see now that these two descriptions are not equal anymore. That the streamlines and streak lines, I'm sorry, the path line and the streak lines are no longer equal. So in fact, they map out a different picture. So if you're following, the key here is that if you're following along with an individual parcel, it will go along happily along this streamline until the flow changes, and then it will follow along this path. Whereas the streak lines of the continuously injected dye will basically have this line of tracer fluid or tracer in the fluid here, and then as soon as the flow regime changes, that tracer will go along this line, and it will push, basically, the flow will basically push this line forward. So I encourage you to look at about the first 13 minutes of this video. This is actually quite a long video, but you can go to this website, and there's a number of great visualizations of fluids put together back in the 60s. It's a little antiquated, but it's certainly very good material. So go to this website and look at the video flow visualization, and this should help you to. And you only need to look at about the first 13 minutes to kind of get the idea of what the difference between streamlines, streak lines, and path lines are. Okay, I hope that helped to get us going. Most of what we'll deal with in this class is steady flow. So most of the times we will not have to deal with differences in these three definitions or these three different ways of looking at flow. But for the occasions when we do have unsteady flow, we will have to consider these. Okay, thank you.